Okay, so good morning, Professor Chen and everyone. This is Group 27, and we're going to present our final project presentation, which is asteroid classification. And here are the group members of our team. Hazardous asteroid has been one of the concerns of humankind, as fallen asteroid on Earth could cause a huge impact on the society. The aim of this project is to use machine learning and deep learning to accurately classify hazardous asteroids. A total of 10 models, which consist of 5 machine learning models and 5 deep learning models, are trained and evaluated to find a suitable model that solves the issue. As I mentioned before, that we're going to use 10 different models. We're going to use 5 different machine learning models and another 5 deep learning models. For the machine learning models, we're going to use logistic regression, k-nearest neighbor, random forest, cat-boost, and support vector classifier. Whereas in deep learning, we're going to use multilayer perceptron, deep neural network, convolutional neural network, recurrent neural network, and LSTM. The dataset that we use in the project are two, which is first NeoWS, which is collected by us, and the second one is Asteroid data, a public Kaggle dataset by Mir Sakomat Hossein. So actually, both of these datasets have different features and different content, but they have one same goal, that is to classify hazardous asteroid. So this is the proposed method for our flowchart. First, we're going to do data collection, and then we're going to do data cleaning, where we remove the duplicates, remove unnecessary columns, and drop null values. And in the second one, we will use data reprocessing, which is to normalize the data, normalize the numerical data, and label encode the categorical data. And then the next one, we're going to do data preparation, where we split the data into two parts. The first one is have a training data, and the second one is test data. And after that, we will train the model. So each training data will go through every model. And finally, we will do model evaluation after the model training. Uh, so here are the results of our training. So the left side is the NeoWS dataset, and the right one is the Asteroid dataset. And as we can see right here on the graph, we can see that random forest and cat-boost have a similar result, but we can see that the random forest in both datasets have less training time rather than the cat-boost. Yeah, but in detail, we can see that this random forest and cat-boost also have similar results, but in training time, random forest perform really faster than the cat-boost. So we will take random forest for comparing to the deep learning model. And here are the results of the deep learning method. So this is deep neural network, convolutional 2D or CNN, RNN or recurrent neural network, and LSTM. And if we look into detail, we can see there are two models that perform well on both datasets, which is the MLP and DNN. MLP perform well on Asteroid dataset, whereas in DNN it performs well on NeoWS dataset. But if we have to compare with the previous model, which is random forest, we will take DNN because it has the best performance on both data. But if we look closely to uh, to compare the DNN and the random forest, we can see that the random forest have better results since it has a 0.99 score. So in conclusion, in classifying hazardous asteroid, random forest perform the best as the F1 score and the ROC is 0.99. So that's uh, all of the presentation for our group. So thank you so much and have a nice day.